All right. Good day, everyone. So, in today's lecture, I'll be solving another question under the concept of altitude system or altitude machine. So, the question says, assuming that M2 is 20 kilogram and M1 is 10 kilogram, and that M2 is initially 5 meters above the ground, determine how long it takes the heavier mass to hit the ground and its speed upon impact. I'm very sure from the first example I solved, we can all determine the acceleration of the system. I told you guys that if you want to determine the acceleration of the system, all you have to do is say acceleration of the system equals g, change in mass, divided by summation of the masses. Then we take our g to be 10. The change in mass is 20 minus 10, which is 10, and the summation of the masses is 30. And then that is 100 over 30. So the acceleration of the system is 3.3 meter per second squared. We can all determine from the first example I saw. So the question says, determine how long it takes the heavier mass to hit the ground and its speed upon impact. Now, before the movement of this system, the initial velocity of the body is equal to 0. Now we have the acceleration of the body to be equals to 3.3 meter per second squared. So we are looking for the time taken for the heavier mass to hit this ground. So what we are going to do is we are going to recall one of the equations of motion, which is S equals V naught T plus half AT squared. Now this S is the distance between the ground, or you say the datum level, and the heavier mass, which has been given to be 5 meters. So I'm taking my S to be 5 meters. So this will be 5 equals, the initial velocity is 0. So 0 times t. 0 times t plus half a t squared. Then I can say 5 equals 0 times t is 0. So I'm having half a t squared. Now our a is 3.3. I'll substitute. That's 5 equals half into bracket 3.3 times t squared. I'm looking for the time, so I'll cross multiply. So that will be 3.3 t squared equals 5 times 2. Then t squared now equals 5 times 2 divided by 3.3. So now I can say t squared equals 5 times 2, then divided by 3.3. And that is 3.0 in the decimal place. So I find the square root of both sides. I take the square root of 3.0. I'm going to have the time, the square root of 3.0 now. I'm going to have the time to be 1.74 seconds. 1.74 seconds. And that is the time taken for the heavier mass to hit this ground or the datum level. The second question says that, and its speed upon impact. Now, how do we get the speed upon impact? Now, we can see from this question that we have the time taken and we have the acceleration already. The initial velocity of the body is 0. The time taken for the body to hit the ground is 1.74 seconds. And then the acceleration of the system is 3.3 meter per second squared. Now to calculate the speed upon impact, we also make use of an equation of motion, which says that the V equals V naught plus AT. This is the velocity we are looking for, the velocity upon impact. So I have V equals initial velocity 0 plus acceleration of the body is 3.3. And the time taken to hit the ground is 1.74. So I can see V now equals 3.3 times 1.74. Then the velocity upon impact is 5.7 meter per second in a decimal place. And this is how we go about this particular question. Thank you very much. I remain Ajadium. I see you guys in my next lecture.